Okay, good morning, good afternoon, good evening, depend on where you are. Hi everyone, thank you for your joining the third webinar of CTCN on energy systems. As you know already, we dealt with two webinars. First one is regarding water energy food nexus, and second one was buildings and resilient infrastructure, especially we dealt with a nature-based solution. So today we'll have three speakers. I will share the okay. I'll not share the PPT file, but I'll briefly introduce today's program. Actually, I'm Suil Kang, Coordination Officer of CTCN Partnership and Liaison Office based in Songdo, Incheon, Republic of Korea. So I'll do moderate today's webinar. So today we have three speakers. First speaker is Mr. Connor Gask, energy efficiency analyst of Energy Efficiency Division of IEA. So he will talk about the role of energy efficiency for developing an affordable clean energy system in Africa. He will have a 15 minutes presentation and then 5 minutes Q&A after his presentation. Second speaker is Ms. Reiko Matsuda-dun. She is a research engineer of National Renewable Energy Laboratory, briefly NREL of USA. She will deliver a presentation on determining and unlocking demand side potential in South Africa. And third speaker is Professor Dinesh Swarup. He is an associate professor of University of Mauritius. He will deliver his talk on feasibility study of anaerobic digestion of the organic fraction of solid waste in Mauritius. It is a CTCN technical assessment project. Actually, the Professor Dinesh has a appointment meeting, so he will join after 45 minutes. So please understand the situation. And then we will have a 10 minutes panel discussion after three presentations. Okay, so now I would like to invite Mr. Connor Gask from IEA. The floor is yours, Connor. Thank you.
Excellent, thank you. And let me just check that you can hear me, and you can see my slides as well. Excellent. So thank you very much, everyone, for joining today. Also, a huge thanks to the UN Climate Technology Center and Network for organizing this webinar, and also the invitation for me to be able to share some of the IEA's latest research on Africa's clean energy transition. I think this webinar comes at a really good time following last week's Africa Climate Summit in Nairobi, where we saw the African leaders' Nairobi Declaration on climate change, and also a call to action to really drive progress across the continent. This included commitments to promote investment in green growth, expand renewable energy generation, promote increased access to clean electricity, and accelerate efforts to decarbonize key energy consuming sectors on the demand side through smart digital solutions and other actions such as energy efficiency. The summit also saw the launch of the IEA's latest Financing Clean Energy in Africa reports, for which some details will be shared in my presentation today. Other insights for this presentation are drawn from our 2022 Africa Energy Outlook, as well as some ongoing research we're looking into the potential of energy efficiency for developing an affordable, clean energy system in Africa. So if we look at the current situation in sub-Saharan Africa, for example, there are currently 600 million Africans without access to electricity, which is almost all of those in sub-Saharan Africa, if you look at the numbers. To reach universal access to electricity by 2030, 90 million people would need to gain access each year on average from 2022. And this is achievable in principle. Between 2015 and 2019, prior to the pandemic, 7 countries came close to achieving the rates of progress needed to achieve full electricity access by 2030, including Côte d'Ivoire, Gambia, Kenya, and Rwanda. And almost 45% of the population that gain access for the first time in sub-Saharan Africa in our Sustainable Africa scenario do so via a grid connection. And this is mainly urban dwellers and rural communities living within reach of existing or planned grids. Nearly 1 billion lack access to clean cooking fuels and technologies as well in Africa. In our Sustainable Africa scenario, 130 million Africans would need to gain access to clean cooking each year between 2022 and 2030 to meet goals. This requires an unprecedented acceleration of action in Africa, although promising levels of progress have been made already in other countries, including Indonesia, India, and China in recent years. Achieving full access to modern energy in Africa by 2030 would require investment of $25 billion per year. This is comparable to the cost of building just one large LNG terminal. Current investments fall far short of these levels. In 2019, for example, this amounted to just 13% of levels needed to meet the goal that I mentioned by 2030. Ramping up access to investment requires programs on the ground to mobilize a large number of smaller projects, which individually are difficult to fund. Looking at growth in electricity demand over the coming decade, Africa is set to experience an unprecedented increase in energy demand, driven by rapidly growing economies and populations, rising incomes, and significant infrastructure expansion. Energy demand in industry, freight, and agriculture is expected to increase by almost 40% by 2030. And as climate change and urbanization drive up the need for cooling, electricity demand for household appliances could more than double by 2030. Industry accounted for 2/3 of energy demand for productive uses in Africa in 2020, with services made up of commercial and public buildings and desalinization contributing 1/4 of this demand. Total energy consumption for productive uses across Africa rises by 33% based on our projections in the Sustainable Africa scenario, with the use of almost all major fuels increasing in all 3 productive sectors. Electricity consumption increases significantly in both industry and services, where electricity meets almost half of total energy needs by 2030, and more than 3/4 of the rise in energy use driven by increasing use of electricity for space cooling, lighting, and appliances. The increase in energy use in our scenario is tempered by the adoption of strong measures to enhance energy efficiency. Africa's 300 million households accounted for 56% of the continent's total final energy demand in 2020, despite 120 million of these households lacking access to electricity and 200 million being deprived of modern, clean cooking solutions. Over the decade to 2030, the growth in household demand for energy services is set to outpace population growth, as rising levels of access to electricity and rising incomes drive up ownership and use of appliances and equipment, as well as other uses of energy. In our Sustainable Africa scenario, most of the growth in demand is met by electricity, and its share of total household energy use rises from 6% in 2020 to over 25% by 2030. Looking at appliances, lighting, and air conditioning and their energy use, rising incomes and expanded access to electricity will drive growth in this sector. We expect that ownership of air conditioners will jump by around 17 million to 40 million, and electric fans will increase to around 340 million between 2020 to 2030. The stock of refrigerators will also increase by over 80 million and washing machines by 20 million. As a result, electricity demand for these and other household appliances and equipment more than doubles from around 160 terawatt hours to 350 terawatt hours. Growth is fastest in sub-Saharan Africa, with electricity use for appliances and other electrical equipment quadrupling by 2030. In contrast, however, to total electricity use, average consumption per household that has access to electricity actually falls slightly between 2020 and 2030. This we expect is due to a rapid implementation of mandatory minimum energy performance standards and also stronger building codes across all appliance types and across building sectors in almost all countries on the continent. Another key challenge which we see in Africa is looking at the resilience and sustainability of the power system. And we have seen growing network losses leading to increased strain on power systems in Africa as well as globally in recent years. Massive investment in Africa's grids is critical to improve system reliability and expand access and facilitate the integration of variable renewables. Extremely high network losses across Africa, which averaged around 15% in 2020, were almost twice the global average of 8%. And countries often lack the tools to monitor the condition of the grids and to accurately assess the location, duration, and cause of blackouts or brownouts. Reliability is particularly important to attract industry and investment in industry, as African enterprises experience power interruptions of more than 50 hours a month on average in 2018, a loss of 25 days of economic activity per year. So addressing power system sustainability not only can improve the economic growth, but also can improve the investment prospects for industry in the future in Africa. We are also seeing some headwinds facing Africa's clean energy investment. Starting out with historic energy investment, we can see spending falling since highs in 2014 and now accounting for less than $90 billion per year. When we look at the breakdown of this investment, the fall is driven by a slowdown in fossil fuel spending, which has not been countered by any significant uptick in clean energy investment. This is despite the fact that the continent is rich with renewable resources. Simultaneous to this drop in energy investment, we've also seen a rise in government debt, and debt servicing costs are more than double the level of clean energy investment. In the energy context, the rising debt poses several challenges. Firstly, it means that there are limited government funds available to support the sector, so external resources and private sector must play a bigger and more crucial role. And secondly, it raises concerns to investors, which is translated along with a range of other specific risks into higher costs of capital. For energy projects in Africa, capital can be 2 to 3 times more expensive, making it harder to finance projects while keeping energy affordable for the end user. Another area which the IEA has been looking more to in recent months is clean cooking. The traditional use of biomass dominates residential energy demand in sub-Saharan Africa today, with more than 80% of the population reliant on it. Universal access to more efficient and clean energy for cooking by 2030 in the Sustainable Africa scenario reduces total residential energy demand in sub-Saharan Africa, as efficiency gains more than offset the overall increase in the underlying demand for cooking. Energy demand by 2030 could drop by 66%, more than offsetting an increase in use for other residential uses, such as appliances, cooling, and lighting. One of the key challenges which we have seen is investment in energy efficiency in Africa, which in the past has been overlooked. We believe that energy efficiency needs to play a key role in Africa's energy economy as demand expands, but it is not yet getting enough priority. Energy efficiency spending increases 7-fold by 2030 in our Sustainable Africa scenario, in areas such as efficient green buildings and consumer appliances like refrigerators and air conditioners. Increased investment in industry as well will also be critical to reducing overall energy demand. Investment in energy efficiency, electrification, and renewables for end use in Africa has been relatively static for more than 5 years, accounting for slightly below $6 billion in 2022. And while several countries in Africa have put in place building codes and minimum energy performance standards for certain appliance types, there is still a lack of an integrated and comprehensive policy framework in many cases. In 2022, for example, MEPs and labels for air conditioners covered around 50% of final energy consumed by all such equipment in Africa, and refrigeration stood at 60%, compared to a global average for both of around 90%. And finally, we see reliable and robust grids as a key missing piece of the puzzle in driving Africa's clean energy transition and decarbonising on the demand side. Electrification of end uses and changes in demand, coupled with increasing shares of variable renewables, are creating pressures for advanced economies, emerging markets, and developing economies alike. Due to underinvestment, electricity systems globally face a myriad of challenges, including inefficiencies, losses, congestion, and outages. Climate change is causing further damage to assets and affecting reliability. We see that grid investments rise from around $10 billion per year today to nearly $50 billion by 2030 in order to meet sustainable goals, requiring new financing models that are less reliant on limited state funds. Many African state-owned utilities struggle with poor financial health and high system losses, which average 15%, as I mentioned before, almost double the global average. As a result, they are unable to finance the necessary expansion and modernization of grids that the influx of renewables requires. This includes expanding digital and smart solutions, which will be critical for driving decarbonization in high energy consuming end user sectors, such as buildings and industry. Alongside efforts to improve the financial health of utilities, achieving the spending increase is likely to rely on grants and highly concessional capital to develop pilot models that shift some of the financing to private players. Countries such as Kenya and Uganda are already testing innovative concession or brownfield asset refinancing approaches with the support of development finance institutions, which could serve as models for elsewhere on the continent if successful. Finally, again, I would like to thank everybody today for your attention, and I look forward to answering any of your questions. Thank you very much.
Okay, thank you, Connor. Very comprehensive and presentation regarding the challenges in energy efficiency and the energy demand in Africa, and then also the future actions to be made in Africa. So it is a Q&A session. So if you have any questions, you can make a question to Connor, or you can use the chat box. So floor is open to you. Thank you. So Connor, actually, in the meantime, when during our audience make questions, I would like to make question regarding the actually IEA's specific program or initiative in Africa. Could you elaborate more on IEA's initiatives or activities in Africa? Thank you.
Yeah, definitely. So I think it's maybe worth saying that obviously there's increased attention on the African continent in previous years, which has really driven growth in the IEA's focus on the continent as a key region for achieving some of the kind of longer term universal goals that we're looking to achieve. To date, I guess a larger proportion of our work has focused on looking into analysis around gaps in policies and investment, which can help countries across Africa to meet their goals around universal access to electricity, for example. So that's been a key driver, I think, maybe historically as well for other organizations looking at Africa in terms of working on driving a clean energy transition. Main focus has been on ensuring universal access. But I think, and maybe it's something which we saw with the climate summit last week, with a strong call for more financing to be made available for driving a clean energy transition across Africa. And that call was led very strongly by Kenya as the hosts. We're looking to expand our focus. And maybe if I mention from a perspective of energy efficiency and the demand side, we're looking to expand our analysis on opportunities in the building sector, both for curbing increasing energy demand. So we see the building sector as the largest growth sector for energy demand in the continent in the next 10 years. But also there's an increasing focus on aspects of digitalization and smart solutions as well. And I think that's something which would cover all end-use sectors. For buildings, for example, it could look at harnessing some of the more digital focused or big data focused innovations in countries in Africa. You could talk about maybe the work Safaricom is doing in Kenya, and apps such as M-Pesa, which can allow for kind of a transition from more fossil fuel based systems directly to more digital and smart systems. So we're looking at kind of a range of different things in Africa. I think on the industry side, it will be interesting to see how priorities for different countries in the continent emerge over the next few years. But I think, again, for energy efficiency, this extends from both traditional approaches of looking at simple switching, say, of electric motors from diesel-based motors to more efficient electric motors, which can help to promote energy savings, but also drive progress on other aspects such as air pollution. But again, looking towards this more digital, smart angle of the demand side and how we can really unlock the potential in this sector.
Okay, thank you so much. Do you have any further questions, please?
Maybe whilst we wait for questions. Oh, I see one there.
Actually, okay. Actually, I can read one. Okay, there is one question from, I think it is Taye, our citizen specialist. Okay. Thank you, Connor, for your insightful presentation. I could see that the needs among standalone and mini grids were almost similar to that of grid in your slide. Could you please elaborate how enabling environment is created in Africa and what kinds of regulations or policies help this scale of decentralized system? You can also read it from the chat.
Yeah, I've got the question.
Okay.
Thank you very much, Day. And yeah, it's a really, really important question. And I think it's something which we have seen, and some of my colleagues who work in much more detail on digital solutions and smart grids have seen, is obviously that a majority of investment in the last few years, especially when looking at clean energy solutions, has been targeted at larger scale centralized grid solutions, whereas financing available for these kind of smaller scale off-grid or decentralized solutions is much harder to access. So I think one of the key kind of policies that we need to see introduced, especially in countries across Africa, is looking to find ways to incentivize a combination, I guess, of state-owned, of kind of state finance, but also private financed investments in decentralized solutions. And this can be a big challenge. I think, again, we've been working quite closely with countries such as Kenya, who've been doing some great work on setting out these longer term policies and plans as part of their broader strategies on achieving universal energy access. And I think one of the things which has been effective in driving success in this is ensuring that when they're developing these larger scale universal energy access strategies, that they provide an equal amount of attention to urban and rural areas. And again, I think your question, maybe one of the challenges is how you look to incentivize investment in urban areas where it's easier to provide increased access and easier to install, or promote digital solutions, whereas in rural areas it becomes much more difficult. So I think it's maybe not a super detailed answer, but being able to shift some of the focus or provide more resources for rural solutions in the future will be really important.
Okay, thank you, Connor. Wonderful answers. Okay, we'll have one more final question. Actually, Owen Rose, he's our CTCN AV chair now. So you can see his question is about digitalization. Actually, can you talk about the potential for virtual power plants and artificial intelligence? Thank you.
Yes, definitely. So thanks, Owen, for the question. And on VPPs, again, I guess it's something which is emerging, but emerging quite rapidly. Actually, one of the other hats that I wear here at IEA is covering China. And I think, in the last sort of 5 to 6 years, we've seen a rapid emerging of these kind of demand side, more AI-based or digital solutions. I think I guess if you take China as an example, its current power system and its power market models are not super liberalized. So some of the models that they've tried to use maybe wouldn't apply effectively onto examples in other countries based on the structure of their own power systems. But one of the kind of fundamental, I guess, key aspects that you need to lay the ground for these types of systems is having a more granular idea of what's happening, especially on the user side, where it's really difficult sometimes to know how very slight changes in demand happen over time. So I think that's something, especially in the African continent, where there is this opportunity to take this kind of jump from a traditional to a more smart focus model and harness some of the innovations that are taking place across the continent would be really useful. One of the key aspects we maybe see for VPPs is looking at industrial parks. So looking at existing kind of sectors, such as an industrial park where you already have a ready collection of energy consumers working effectively within, you can't say one system, but they're already relatively connected. So there's an opportunity there to kind of apply big data or AI solutions that can then collect the data that you need to then try and implement a model such as a VPP to help better manage fluctuations in demand in the future. But I think it's something which is growing very fast, and it's one of those areas where if we don't pay attention to it right now, it's easier for it to kind of get ahead of us very quickly.
Okay, thank you, Connor. Thank you also three audiences who made the questions. Okay, now we'll move on to the second speaker. Actually, if you have during presentation, if you have any question to previous speakers, please use the chat box to type your questions there. Okay, so now we'll invite Leiko Masuda-dun from NREL. Okay, the floor is yours, Leiko. Thank you.
Thank you. I'll share my screen right now. And can everyone see my slides? All right. And can everyone hear me all right?
Yeah, we can hear you.
Okay, so my name is Reiko Matsuda-dun, and I am presenting work that I have done with other team members at the National Renewable Energy Lab, or as we call it, NREL, on determining and unlocking demand-side potential in South Africa. Start with a bit about what we do at NREL. So NREL is a laboratory of the U.S. Department of Energy. We are an applied lab, so while we as researchers love to think about theory and advanced science and technology, we want all of our work to be implementable. Our research sits in 4 main sectors that drive U.S. innovation. That is in renewable energy, including solar, wind, geothermal, and hydro technologies, sustainable transport and fuels, including bioenergy, EVs, and hydrogen technologies, buildings and industry, including building technologies, of course, advanced manufacturing research, and energy management programs. And then finally, energy systems integration, which is where much of our team sits, where we focus on grid modernization and resilience in the face of natural hazards and cybersecurity. So some of the work that we have done here, just a little bit about that. It is funded by CTCN. Thank you, and thank you for hosting this webinar. The technical execution was led by us at NREL, and we have partnered with CSIR and the Department of Science Innovation in South Africa, along with other key stakeholders in the energy sector of South Africa to inform this work. Our project overview is here. Our structure was defined by 4 sequential tasks. So first, characterizing current demand-side management efforts in South Africa, and I'll spend a bit more time on the next slide talking about demand-side management for those who are unfamiliar with it, or if you are familiar with it, it's a nice refresh on the many different broad topics that DSM can cover. So we want to characterize these efforts in South Africa and baseline DSM projects around the world. Next, we identified the end uses in load sectors with the potential for the most impact. So understanding which end uses could be targeted to reduce demand at the most critical times. And then in terms of the sector, we found often that in the industrial sector, there might be a large consumption of energy, but the industrial sector is largely flat, whereas the residential and commercial sector is the greatest demand we see during the peak loads. So those are the sectors that contribute to the most strain on the system at those times. Our third task was to quantify the benefit of a specific DSM application, building on the findings from the previous task, and this rolled into high-level program design. So finally, that feeds into our last step of deploying a pilot of this technology, or identifying the steps to deploy a pilot in this technology in the field. So a bit about demand-side management. So this is a taxonomy of DSM solutions. What is demand-side management? So in balancing the power system supply or electric energy generation with demand, or electric energy consumption, DSM programs involve modifying demand to meet supply constraints rather than generation following customer load. So here we have DSM under these 3 categories. We've got energy efficiency on the far right, which we've just heard about. This would include things like building insulation, but also energy efficient lighting and appliances, or different types of technologies to produce the same end result with less energy. Distributed generation is another option. So these would be things like PV, hydrogen systems on the distribution side, or more advanced technologies like V2G. And then we have demand response. There's a lot of different categories of demand response: dispatchable, non-dispatchable, controllable, and this kind of comes down to the level of direct control that an operator can have over these different technologies. So part of the challenge of identifying new DSM applications in South Africa is that so much effort has already been put into this work to date. So our approach of systematically defining DSM solutions helped us to be sure that no stone was left unturned in our work. So I'm already provided a little bit of information about the challenge, but South Africa is facing capacity constraints that have been leading to load shedding or widespread service shut-off to customers, also known as rolling blackouts. So some may be asking why this extensive effort into DSM implementation. This is a supply-side problem, but DSM can help to alleviate this imbalance of supply and demand. So demand-side management can help reduce the peak demand. It can shift the load to flatten the profile. It can achieve energy efficiency, reducing the strain on the system during these peak hours. South Africa, as I mentioned before, has already had a large DSM program. A lot of this work has targeted large industrial customers. So this is an area where a lot of the effort has already been applied. What we have identified as small and medium customers and domestic customers may have untapped potential for DSM programs. And the graphics on the right here just sort of characterize the system from a very high level. Much of their generation comes from coal. And then South Africa is a winter peaking system with a peak in July of around 35 gigawatts. Right. So moving forward into the load shedding, and my slides have a little delay here, so apologize for that. Great. Okay, so load shedding, as I mentioned, is a supply side problem. So here we have in the blue trace the energy availability factor. So South Africa, while they do have much of their capacity built out to exceed the peak demand, the challenge is the low energy availability factors. So here you can see over the years as the energy availability factor has decreased, but the percentages on the left axis, we see an increase in manual load reduction up to over 6 gigawatts, nearly 7 gigawatts for some periods of the past couple of years. So as the energy availability factor worsens, so does the load shedding. And then on my next slide, I'm going to discuss some of the untapped potentials that we identified on the demand side as soon as it advances. So some of the energy efficient technologies we identified were water heaters driving peak demand in South Africa. So some of the solutions to address specifically water heaters as an end use include expansion of ripple control, which was already implemented in South Africa. The current capacity for ripple control is around 200 megawatts. There's potential of over 2 gigawatts. Solar thermal technologies could reduce electricity consumption by 40 to 60%. The challenge there is some solar thermal water heating has an auxiliary element to it. So that could actually increase consumption. It's difficult to quantify that amount. Timers on devices could help shift the load away from winter peaks. And then heat pump water sources, heat pump water heaters could reduce electricity consumption by nearly 2/3. Nighttime storage heaters could shift the peak, but they are not, in fact, energy efficient. They are only peak shifting, so they consume more energy in the evening to then heat the home during the day. And then finally, there are other efforts that are maybe not falling under appliance side energy efficiency, but AMI smart meter rollout has potential to improve demand side management. Some of the challenges there are just the supply and the timing of smart meter rollout. So this is something that we expect could really benefit many different systems, but the challenge is rolling out millions of meters and enabling them. Finally, we identified emergency alert programs, which have been used in the US. The wireless emergency alert system that we have here notifies customers on your phone. You don't even have to sign up for it. And we've seen actually impacts in decreasing the demand of the system from around 4 to 8% in California and New York. All right, so on the next slide, I'm going to talk about load shedding as a barrier to DSM programs. So load shedding has the challenge of reducing the benefit of other DSM programs. You cannot implement both at the same time. There cannot be a benefit from a DSM technology if that portion of the system in which it's deployed is load shed. You can't have both. So while we have this potential benefit of DSM programs that we identified in our work, up to 2 gigawatts, none of them can compare to the amount capacity that load shedding provides, which was nearly 7 gigawatts in 2022. So here we just have the degree of load shedding that is occurring. In July, it was kind of constant for up to 18 days, coming up to 7 gigawatts. So the extent of load shedding that is currently being relied upon cannot be overemphasized. So we had over nearly 4,000 hours of load shedding in 2022, which is about 43% of the year. So the takeaway is that load shedding is not going anywhere in the next few years. The challenges of current load shedding are that it's performed by the municipals and ESCOM. ESCOM is the primary transmission system operator and generation owner. Load shedding takes place at the feeder level. So on a feeder are possibly thousands of customers. Entire communities are load shed. There is no means of isolating critical infrastructure, such as hospitals or other services that can really improve quality of life for the people on that feeder. So the impacts of that is that those critical loads are shed. Customers are locked into blocks of being load shed or without service for hours at a time. We've got 4-hour blocks at the moment. The comeback load on each of the feeders upon re-energization can cause issues. So it's not always easy to just re-energize the circuit after it has been load shed because of that large load. And then theft of electrical equipment is high when the feeder is de-energized. So during these load shedding times, that's an opportunity to actually steal distribution transformers and the copper in them. And then that circuit can't come back online right away without that service. So our proposal is to use targeted demand response to reduce load shedding impacts. So surgical or targeted demand response is about de-energizing at a more granular level, so at the customer level. This is something that has been done in the US or has been implemented with AMI rollout. So most AMI meters are equipped with AMI remote turnoff, so they can shut service off and restore it remotely. But it doesn't necessarily rely upon AMI. This could also be done with smart circuit breakers and appliance level relays. And the advantage of this is that you can isolate critical loads and maintain service to those critical loads. You can rotate customers faster, and you can introduce some geospatial diversity. So as a customer, you might have an option of going to a nearby premise that has energy to find heat or cooling, those critical services that you might need. This also alleviates the comeback load issue because you can stagger customers a bit more. And then finally, that customer rotation could be 15 minutes as opposed to 4 hours. So being without power for 15 minutes, preferable to hours at end. So to quickly summarize, supply side solutions are critical to addressing the current energy crisis in South Africa. but demand side management programs can help customers and alleviate the system strain. Energy efficiency in particular can benefit customers through reducing consumption and their bills, therefore. So these are efforts that we think are important and should be continued, but they are well understood. So that's why our work has focused on these smart dispatchable loads. These programs, they're great, but they will not provide benefit to the country unless they are designed as an alternative to load shedding. And target demand control can provide benefits as an alternative to load shedding. So targeted surgical demand response could be enabled through AMI or smart metering infrastructure, which has multiple stacked benefits. All the benefits of AMI can come if you can create this rollout at the same time as targeted demand response. So finally, I just want to say thank you to all of you attending, and thank you to CTCN for hosting.
Okay, thank you, Leiko, for the wonderful question. So it's time for the Q&A session. So if you have any questions, please. So like, okay, there is a, yeah, sure.
I see someone is
load
shed right now.
Yeah, Oscar, please, floor is yours. Can you turn your mic and then raise the question to Leiko? Okay, he's.
Oh, I'm not sure if participants.
Oh, let
sure.
Let me try. Am I audible?
Yes.
Okay, thank you. Very interesting presentation overall, I must say. But like I said, I'm almost sitting in the dark as we speak because of load shedding. And my apologies for being late in your presentation or in this engagement. And you may have mentioned this already. I was trying to figure out who your let's call them research partners are in South Africa in dealing with this issue of load shedding, because I'm not certain whether you have the whole picture, because besides the whole technology challenge, our problems in South Africa are bigger than that. I mean, our infrastructure was not designed to capture for the current population, including, I mean, you know how porous our borders have become, everybody who is now moving into South Africa. So it's not only technology challenges, there are all sorts of socio-political issues. And I was trying to figure out whether in your approach, are you factoring all these things so that maybe you can render more sustainable solutions, to the challenges we have? Thank you.
Yeah, thank you so much for that question. I think you've really highlighted the challenge of trying to address a problem with sociopolitical contributors from a technological perspective. And yeah, we are limited in that capacity. I think the challenge, as you've characterized it, I'm understanding that there is demand growth in addition to the current demand that we see right now. That's kind of contributing to those low energy availability factors. And I think the way that we're addressing this is that these technologies we've identified can help alleviate those from multiple angles. So including those energy efficiency programs we've highlighted, along with this targeted demand control that we could introduce, that can introduce some of that grid modernization that can support that load growth, as well as the integration of additional distributed energy resources. To address your question about who our partners were, so we've been working with CSIR, DMRE, and ESCOM on this. ESCOM is more of a stakeholder that's provided us with some data, whereas we've been collaborating very closely with CSIR. So yeah, I agree the problem is complex. As I mentioned, the challenges are really on the supply side. So we are trying to understand what we can do on the demand side to alleviate those issues, but it's not going to be a single solution that's going to magically fix everything. Does that address your question? And I know that there's probably some gaps there that, acknowledging that no single technology is going to completely change the situation is kind of unsatisfactory, but hopefully, that helps. So yeah, let me know if there are any other specifics that you would like me to address.
No, thanks. I think I'll leave it at that. I'll pick this up because I work for the CSIR.
Okay, great. Yeah, we've been working with Peter Mukoma, and we'll be.
Yeah, no, I know Peter
Yeah.
very well. Yeah.
Yeah.
Okay.
So he's been great. And we'll be at CSIR next week.
Next
so
week. Okay.
Maybe you can join us. Yeah.
I'll make sure I'll yeah, please. Maybe through Valentine, let's just make sure that I'm invited to that meeting. But thanks for your response. Thank you.
Great. Thanks for the question.
Thank you, Oscar, for the question. And then I really hope that this current project really provide practical solutions and then really solve those challenges completely in the near future. Okay, so if you have more questions to Reiko, please use the chat box during the presentation. Thank you, Reiko. Actually, we can talk more at the panel discussion.
Yes.
Thank you. So now we would like to move on to the third speaker, Professor Dinesh Sloop. He's from University of Mauritius. During his busy schedule, he joined us for the presentation. Thank you, Professor Dinesh Sloop. The floor is yours. Thank you.
Thank you very much, Phil. I just wanted to check if you can see my slide properly.
We can see.
Okay, very good. Thank you very much. So it is indeed a great pleasure to be among you guys. I am going to present the technical and economic feasibility study for anaerobic digestion of organic fraction of solid waste in Mauritius. I just wanted to make it clear what is our role in that project. This is a project that was funded under a TA by CTCN for the government of Mauritius, for the Ministry of Environment more precisely. And it was undertaken by CSIR from South Africa. And we were one of the partners on the technical aspect. So I'm going to just to share some of the findings of that project. So solid waste generated in Mauritius emanate mainly from domestic, commercial, institutional, and industrial sectors. The composition of the different components constituting these waste streams are highly variable, with some waste streams higher in organic waste, while others possessing higher recyclable component. Just for information, before we started this project, this TA, we had at the university, we had already conducted another study on the characterization of the municipal solid waste in Mauritius, again for the Ministry of Environment. And the findings from that study was actually very helpful on the way forward to undertake this project. So the findings were as follows. This is the composition of municipal solid waste in Mauritius. So you can see that the yard waste, paper, and food waste constitute the biggest chunk of the solid waste management, the solid waste composition in Mauritius, and they are the majorities. And we also have plastics and metals and glass and textile. If we look at the characterization of the waste, it is highly humid. So the moisture content of the MSW is almost 33%. The ash content is 8%. And the gross calorific value is 16 megajoule per kilogram. And the net calorific value is slightly less than 9 megajoule per kilogram. And the DOC, degradable organic carbon, is 0.15 gigajoule carbon per gigagram waste. So I'm sorry, the unit I just mixed up. So the DOC is 0.15 gigagram carbon per gigagram waste. So this was the finding from a previous study. And from that study, the way forward was to come up with several options for managing waste. Obviously, one can be waste to energy, direct combustion, but it also can be the anaerobic digestion production of biogas. And this TA came at a very timely manner, because here we had to analyze the current value change for organic waste across collection, transport, treatment, and disposal, quantification of biogas and energy production potential, identification of appropriate technologies and processes for anaerobic digestion, and eventually a cost analysis to see if this kind of project are feasible or not. So just as information, for generation, so the organic solid waste is generated mainly from the domestic sector, hospitality, that is all the hotels, institutional sector, agricultural sector, forestry, industrial sector, and obviously the market, that is a vegetable market. And the collection is ensured by the local authorities. We have 12 local authorities in Mauritius, 5 municipal council, and 7 district council across the island. And they offer a service of door-to-door. The waste collection takes place at least once weekly for domestic sector and at least twice for commercial sector, with a collection coverage of 100% over the island. There are some pictures of the truck while collecting the waste. The next step, once the waste is collected, it is transported by the local authority to the transfer stations. So we have 5 transfer stations in Mauritius, and in those transfer stations, the waste are compacted, and from there on, the compacted waste is transferred to the only landfill that we have in Mauritius. From the management of the transfer station and the transportation from the transfer station to the landfill and the management of the landfill is taken care by the government. That is, it is under the responsibility of the Solid Waste Management Division, which falls under the Ministry of Environment. So if you look at this map, you can see the red circles. They are the transfer station across the island, and the black one is the only landfill that we have in the country. So you can see the waste collected in different regions or eventually sent to the landfill. You will notice that in the south, there is no transfer station, and all the waste in the south goes directly to the landfill site. The capacity of the transfer station ranges from 100 tons per day to 450. So you can see the years of operation and the design capacity on this table. So the latest one is La Chaumière, which has a capacity of 350 to 450 tons per day. Just for those, I'm sure that you know, but for those who doesn't know, anaerobic digestion refers to the microbial degradation of organic matter in the absence of oxygen to produce biogas and digestate. And the anaerobic digestion involves the breakdown of organic matter by anaerobic microorganism in the absence of oxygen. I'm sorry of this picture. I think that part of it is missing, but the gist is here. So basically, it's a process where you have organic waste coming in. You have bacteria that degrade those organic matter into biogas, and the biogas can be used as a source of energy. And you have the digestate, which can be used for composting as fertilizer. So the biogas can be used directly for cooking, for electricity generation and heat recovery, or even upgraded to biomethane for the use as transport fuel, whereas the digestate can be used as organic fertilizer or composted with fresh waste. So common feedstock that have been subjected to the anaerobic digestion process include organic fraction of municipal solid waste, food waste from hotels, restaurants, yard waste, agricultural residues, animal manures, and municipal sewage sludge, industrial wastewater, slaughterhouse waste, among others. But in this study, we focus on the organic fraction of municipal solid waste, the food waste, and the yard waste. So the next thing is, what type of technology are we going to use for the anaerobic digestion? The technology varies. We have technologies that are on batch operation, that is single stage batch system or multi-stage batch system. We also have many on continuous basis, single stage low solid system, single stage high solid system, multi-stage low solid system, and multi-stage high solid system. The next challenge is to determine which technology is more appropriate. And for this, we have used tools like multi-criteria decision analysis, MCDA, using the simple multi-attribute rating technique. And here we have a series of attributes or criteria that were used to allow for the selection of the most suitable anaerobic digestion technique in Mauritius. And each criterion was also assigned a weight based on its importance as opposed to the other criteria. Now, this assignment of weightage, we have done it together with the authority, with the main stakeholders, that is the different ministries, the different partners on the project, and all authorities that are connected with waste and energy. And from here on, these are the criteria that we have used: waste suitability, investment cost, operating and maintenance cost, land requirement, complexity of construction, operation and maintenance, control on the digestion process, capacity, scalability, temperature regulation ability, and presence of agitation in the system. And when it comes to the types of systems, these are the 6 systems that we have used. And eventually, together with the main stakeholders, we have found that the continuous single stage high solid one is the best for the country, for the island, and therefore this kind of technology was selected. So basically, the single stage high solid is the most appropriate one, and the digest system that are commercialized under this types of system are Dranko process, Compo gas, and Valoga process. So here we are done with the type of technology. The next step was to determine how much of energy or product that we are getting and how is it in terms of economy. So the TA was made for a capacity of 100 tons per day, 100 tons of organic fractional municipal solid waste per day. And the electricity generated annually was found to be 14 gigawatt hour. And we have taken an example of cost of electricity of 3.5 Mauritian rupees per kilowatt. And based on this, we get a revenue of roughly 2.1 million USD. Now, it is important to know that the revenue comes from the sales of electricity, the sales of compost, and the revenue from tipping fee. So if you look at this table, which gives you a much better indication, we have a revenue basically from sales of electricity, compost, but we had to bring in the tipping fee in order to make this project feasible. Business as usual, when waste is coming to landfill, there is a cost associated with the management. Now, if we are diverting it from landfill, I think this amount of saving can be used to fund the tipping fee. Now, we have tried to see what are the different scenarios to make the project feasible. So we have made a sensitivity analysis on the price, selling price of electricity. So option 1 was a cost of 5 rupees per kilowatt. Option 2 was 4 rupees per kilowatt, and option 3 was 3.5 rupees per kilowatt. This is the figure that I've shown in the previous slide. And based on this, option 3 at a price of 3.5 rupees per kilowatt hour, the project is not feasible. You can see the IRR is 11%, whereas at ₹4 and ₹5 respectively, the project is feasible with an IIR less than 10%. At ₹5 it is 6%, and at ₹4 it is 7%, and the payback period is 7 years for option 1, that is ₹5 per kilowatt hour, and 8 years at ₹4 per kilowatt hour. So this was a project that we did for a particular region. So we have chosen the East in this case, because there you have lots of hotel and you can easily get the organic waste. And the capacity of the plant was only 100 tons per day. So we cannot take all the waste from Mauritius. So to conclude, the continuous single stage high solids anaerobic digestion is the most suitable technology. The selling price of electricity must be at least ₹4 for it to be feasible. So we have seen that ₹4 and ₹5 are feasible. Less than this, at 3.5, it is not feasible. As it is now, the ball is now in the court of the authority when it comes to implementation. The project has not yet been implemented, but we are looking forward for them to go ahead with the implementation. Once it is implemented, we can replicate this kind of project in other regions. Thank you very much for your attention. If you have any question, I'm happy to answer you. Thank you.
Thank you, Dinesh, for the wonderful question. So the floor is open now for question and answers.
Just for your information, I have also my colleague here, Oscar, from CSIR. So if you wish, you can just add something. Otherwise, I'm happy to answer those questions.
Yeah, actually, Professor, could you stop sharing the slide? I think that, yeah. Thank you. Okay, so floor is open to audience. Okay, okay, so I have one question to you. Actually, I know that the Ministry of, RINE ministers are also involved in this project. So, you think that when the output of this TA can be, the result recommendation, you already made that specific conditions for anaerobic digestion. It is so. You think that when you think that RINE ministry will buy the outputs of the TA project? So, yeah.
Yeah, I don't know when they are going to implement it, but it looks like they were very happy with the findings. And it appears that this is one of the outcome they were looking for, because they have a problem of increasing amount of solid waste, and the land in the landfill is almost saturated. So they have to find another option. Obviously, the most easiest option is waste to energy direct combustion, but it has its problem associated with it. Also, for a small island developing state, it will have to come at some point of time. But I think as an intermediate solution, I think the waste to energy through anaerobic digestion can be one of the solutions. So they buy in those findings. They were agree and happy with those findings. When it comes to implementation, we have even come up with a draft PPP, that is public-private partnership. But then when it comes to implementation, they have to mobilize funds. They have to look for private sector extra, where we don't have much control.
Thank you. I think that Oscar made a question to you. So I think that you can also check the chat box. So his question is, any developments on the use of refuse derived fuels, RDF, or relevant policy development in Mauritius? That is his question.
Yeah,
Could
thank you.
you-
Thank you very much, Oscar. In fact, you are one of the project partners, so I would rather put that question back to you. So it was just a joke. So let me come to this. Indeed, Oscar, when we were doing this project, there was a famous RDF, what we are going to do with RDF, etc. And in the meantime, what has happened, the government has, one of the measures in the budget was to come up with a biomass framework, because we also had a commitment to phase out coal by 2030. So we should come up with a biomass framework, not to replace entirely, but partly the coal can be replaced from the biomass. And I'm glad to share with you that this year, the government, the cabinet has approved the biomass framework. And the biomass framework is going to consist of all the agricultural waste, like you have cane tops and leaves. We have a big sugarcane field in Mauritius, so cane tops and leaves. It's going to be wood from the forest. And one of the component is also waste from MSW, which is the RDF. So the biomass framework is there. Now it comes to implement, the price are there, the price of the biomass are there. Now it's just a question of implementation. I think that there is an implementation committee that has been set up, and they are implementing the cane tops and leaf first, but those two are going to follow very soon. Thank you.
Thank you. Are there any further questions? Okay, if you really become to have questions, please use the chat box. Okay, so thank you, Professor Dinesh Slu, for your the presentation. Okay, so from now on, we may have like 10 minutes panel discussion. So, I mean, even during the panel discussion, if you have any questions to the speakers, please use the chat box. So I'll try to make specific questions to speakers continuously. So, okay, we will have 10 minutes from now on. So first, I would like to make 2 questions to Connor from IEA. So like first question is, could you like elaborate how IEA implement project in, for example, Africa? I mean, what kind of modality or fund? How do you use those resources when you implement programs in Africa? That's the first question. And second question is, okay, based on your today's presentation, could you recommend what kind of urgent actions or policies or actions to be done for to tackle the energy efficiency challenge in Africa? So did you fully understand the 2 questions?
Yes, I think so.
Okay.
Yeah, I'll start with question 1. So thanks, Will. Yeah, so I think so for IEA, the type of work we do is much more research and analysis based. So we don't necessarily go down to the individual project level in terms of the work that we do. In terms of the model that we work for example, in Africa, in South Africa, for example, it involves working with organizations such as DMRE and Sanadi. So most of our work in South Africa, if you use that as an example, has looked at buildings and appliances sectors. And some of the work from that, we try to make it as demand-led as possible. So we speak with our government stakeholders, our stakeholders within relevant research institutions in country, but also industry partners as well, to try and understand what the key challenges are. And then we will maybe look to do a kind of larger piece of work, which could look at a roadmap, for example, a roadmap for industrial decarbonization for a specific country, and look to analyze different aspects of the opportunities and barriers there are. So maybe looking at regulatory challenges, for example, what is the structure of regulations and policies on the demand side if we're talking about energy efficiency. In detail, we might look at things such as building codes, for example, and what within a building code in a specific country in Africa, what are the elements in there that encourage investment or adoption of energy efficient solutions such as heat pump, or an improved buildings envelope, or broader aspects such as how you drive investment in a country in rapid refurbishment of buildings, for example. So the work that we do can vary quite a lot depending on the needs or the requests from the countries we work with. Maybe a specific example now that we're working on in Kenya is we're working with the Energy Ministry in Kenya on a paper on energy efficiency, where we're looking to identify the opportunities in buildings, appliances, clean cooking, but also on the distribution system side. And what are the current developments? What has been done so far? But then what are the existing gaps? So that's the kind of model we choose and how we work. In terms of maybe short-term actions, I think if we're looking at Africa as a continent, and maybe again drawing on what we saw with the discussions at the Africa Climate Summit last week, one of the short-term actions that needs to be taken is simply making access to financing more available, because it's clear that there are big challenges for countries across Africa in accessing different types of financing, whether it be concessional, whether it be from MDBs, or whether it be from the private sector. So I think one step is looking to develop viable projects for investment or business models which are designed to suit the local conditions. Then a next step is producing these kind of longer term strategies and plans from government, which then send a signal to national or international investors or other stakeholders, that these projects can be low risk, and that you de-risk these projects to allow for scaling up. And then maybe another short-term action is, a lot of, especially for energy efficiency, a lot of the solutions don't actually cost much. And I think, we did a report on clean cooking last year, which found that, the total investment needed to solve access to clean cooking at a universal scale really was minimal compared to other types of investment, say on the generation side, in terms of renewables, solar and wind, for example. So I would say those are kind of the short-term options that you could take, but it needs to be underpinned by longer-term strategy and signals from governments themselves.
Yeah, thank you so much for the wonderful answers. Okay, now I'll give 2 questions to Laker. First one is, okay, you already identified some challenges and potential solutions. First question is, could you elaborate more what could be like a future part of the project to be done in the future? And then the second one is, during the TA implementation, I wonder how much you can see the building of endogenous capacities of local stakeholders through the project. So first one is about the future directions, activities to be done. And then second one is how much endogenous capacities were developed, you think, that local stakeholders. Thank you.
Yeah, thanks for those questions. So for the next steps for our project, we have outlined sort of high-level implementation steps for a pilot project for this targeted demand response. We've identified some of the requirements that would be needed for this, but I think at a minimum, identifying a single feeder where we could test drive the technology. There's a lot of different communication architectures that could be suitable for this. So finding the appropriate one per distribution system and per geography is critical. And so ideally we would have multiple feeders that we could look at. Some of the advantages of this technology are that you can implement load shedding on more mesh urban networks, where you're still isolating critical loads, whereas historically we see challenges of the mesh urban network, the downtown networks that would be load shed. It's an all or nothing scenario. That might no longer be the case. I think we could also look at the ways that this could stack with other kinds of controlled load. So load limiting, which I know there are already pilot programs for in South Africa of a limited amperage that could be extended to customers. So how this communication infrastructure could support similar projects. And then of course, I mentioned the stack benefits of AMI. So I think those are the next steps that we would like to see for the project. For your next question of the implementing and increasing the capacity of the stakeholders, our next steps also involve working more closely with distribution utilities and distribution operators. So I think that would be a question maybe to ask them directly. But we are also working with ESCOM and CSIR. I know for ESCOM, I can't speak to the most immediate urgent needs. There's a lot going on. I think it's a really challenging scenario, but I think one of the gaps that we've identified is that immediate rollout of AMI is going to be a huge undertaking. So identifying those supply chain opportunities, I think is going to be a great effort there that can really help as well. I see Oscar has a comment. Indigenous knowledge systems should be well documented, monitorized, and made part of a bottom-up and top-down decision-making process as part of a public-private sector partnership. I absolutely agree. As I mentioned, I think each of these communication systems and each of these technologies that we are looking at needs to be customized to the particular system. And when I say it's a particular system, I'm thinking the distribution system and the electrical system topology, but also who is there and who are we talking about? So one of the steps that we want to take is kind of combining answers to questions 1 and 2, is understanding customer preferences with this kind of technology. So I think implementing a survey to understand, what the actual preferences of the people experiencing this technology are, and making sure that we can accommodate that as we roll out the technology is really important. So thanks for that input, Oscar.
Thank you, Leiko, also for the wonderful answers. So now we'll have questions to the Professor Dinesh Sulu as the final part of the webinar. Okay, so actually here Oscar also, I think he raised some questions in the chat box that can I ask the expected challenges when it comes to the implementation phase for the anaerobic digestion technology in terms of the target region environment? So he expects the challenges to, and then another, my question is that, can you explain how much really this CTC TA project support or help your capacity building in the University of Mauritius? That's my second question. Thank you.
Thank you. Thank you, Stuart. Let me take the second question first. I think when it comes to capacity building, one of the objective of the project is to develop capacity locally. So I think we are very grateful to CTCN for having given us opportunity to work on this project, because it also provided us to show what we can do when it comes to feasibility study. It's true that when the project started, we didn't have a clear picture what are we going to get as an output. But I think during the course of the project, we've lots of challenges, constraint, discussion, consultation. I think we managed to come up with this product. So I think, yes, this project has empowered us also in that field. So I think we are very grateful, and I would like to put this on record. So we thank Mr. Garg and Mr. and Valentin, who was always there to support us, to query whenever needed, because sometimes the project wasn't going as it should have been, and it was during the COVID period, so during the pandemic. So I think we are very grateful to them. Let me come back to the question on the chat box. I think it is from your colleague Hayun. So thank you very much for this question. Yes, indeed, there are lots of challenges when it comes to implementation. The waste as it is currently, it is not segregated. So all the waste are mixed. The organic, non-organic, everything is mixed. So for the implementation of this project, what we need is to do source separation of the waste right from the start, from the household level. So we need to have a change in mindset. We need to have investment in terms of different bins, and we need to have a very good logistics in terms of collection of those waste, because it will require additional transportation of the waste from the source of generation to the plant. So these are the main challenges that I think. I think that for it to be implemented, we need to come up with a strong policy decision in terms of source segregation. When I'm saying a strong policy decision, it will also entail penalty those who are not complying with those regulations. Thank you.
Okay, Professor Dinesh. Actually, I made a mistake. The person who raised the question was Hyunsin Kwak. Okay, so Hyunsin also made another question is, or any challenges related to the policies? Can you reply to the question?
Yes, the challenges just as I touched upon is to come up with policies for source separation. This is not in the culture. This is not something that people practice. It is done, but on very isolated level. It is not nationally. Everyone is doing source separation and doing composting. It is being done, but not by everyone. So I think those are challenges when it comes to the policies. That's why I say when we come with the policy, we should also come with the penalty those who are not complying with those policies.
Okay, thank you for the wonderful answers. Okay, I think there is time to close the webinar. It's already we had 1 hour and almost 30 minutes time here. So first of all, I'd like to really appreciate 3 speakers' great contribution and commitment. Actually, it is like early morning in USA, and I really appreciate your contribution again. And then your really insightful presentations and comments, and then policy, identifying challenges and providing solutions to those challenges are really helpful to like a local regions or national and regional level. So thank you so much. And then actually we will have a 4th webinar on 16th October. So it is on the business and industry. Is one of the CTC and system transformation areas. So at the October 16th same webinar, we will invite a global cement and concrete association, and then Expo Live from UAE, like Jasmine Baker. She will deliver some entrepreneurship activities in UAE before the COP28. And then we'll have one innovation company in Korea which support startups and entrepreneurships. So we'll deliver 3 presentations regarding the business industry on 16th October. So we hope see you again in October. And then we really appreciate your to the audiences during very early on time or late time you joined to the webinar. We really appreciate it. Okay, so have a nice day, everyone, and then thank you so much. So see you again. Yep. Bye-bye.
Thank you. Thank you. Bye-bye.
Yeah, thank you. Bye-bye.
Thank you.
Thank you.
Yeah.
Thanks, everybody.
Bye.
Bye.